So in this final tutorial, I want to talk real quick just about ATP kinetics. So what I want you to remember is this process where ATP is becoming ADP and an inorganic phosphate. This process has a delta G that is equal to approximately negative 7.3 kilocalories per mole, making it spontaneous, making it exergonic. This energy can be used to fuel other reactions. So for example, if I had some arbitrary reaction where X plus Y yields some product XY, and it had a delta G equal to 1.3 kilocalories per mole, the first question is, how would we classify this reaction? Well, it's got a delta G greater than 0, so we would classify it as non-spontaneous and endergonic, meaning we would need to put energy in. And the question I might ask you is, how much of this, or how many molecules of ATP would we need to put in to fuel this reaction? And all you have to do to figure that out is figure out how many molecules of ATP you need to make this number become negative. So in this first example, we have 1.3, and then we're adding a negative 7.3, which is going to give us a negative 6.0. This is less than 0, so that means our delta G is now less than 0, which is exactly what we want for this reaction to proceed. So here we have accomplished this. Okay? We've added negative 7.3 and 1.3, giving us a negative 6.0. So the answer there would be that it takes one molecule of ATP to fuel this reaction. All right, so let's look at a second reaction. Let's say we're still dealing with X plus Y, but this time, let's say that we have a delta G of 12.6. Okay, so if you look at this, first and foremost, you'll recognize that 7.3 is not going to make this become negative. So if I try just one ATP molecule, then essentially I'm subtracting 7.3 from 12.6, and it's giving me 5.3. This is still positive, and it's still greater than 0. So we are not at the point where the reaction is spontaneous. To get there, we're going to have to add a second ATP. So here comes another ATP, negative 7.3. So 5.3 minus 7.3, or plus a negative 7.3, is a negative 2.0. At this point in time, we're at negative 2.0 kilocalories per mole, and we are now finally at a delta G that is less than 0. So it took 2 molecules of ATP to make this reaction proceed. So that's really all you have to do if I present a question similar to this one on the exam. So that's it.